Hello my dear students, this is Akash SD and welcome to the ASD Physics classes. I hope so you all are doing really great. So students, in this video we are going to learn about the mutual induction from the chapter Electromagnetic Induction. Okay, so let's learn the concept with the NEET 2021 question. Okay, so students, the question is, see please, NEET 2021 question. Two conducting circular loops of radii R1 and R2 are placed in the same plane with their centers coinciding. If R1 is greater than R2, the mutual inductance capital M between them will be directly proportional to. So here four options are there. Okay, so whenever the question is coming from the mutual inductance, we should know the steps involved to solve the question based on the mutual inductance. And please remember that whenever we are calculating mutual inductance, there will be two coils. One will be primary coil and another one will be secondary coil. Okay, so let's see the steps here. Now, so see please, steps to calculate mutual inductance. Here we are doing for the coil, but it is applicable for any kind of situations. Okay, any kind of coil is there. Maybe circular coil, maybe coaxial solenoid, or maybe square shape coils, rectangular shape coil, any kind of coil, these steps will be valid. So see please, first one, assume any one of the circuits as primary and the other as secondary. As I told, two will be there, one primary and one secondary. Second one, suppose current I1 flows through the primary circuit. Now, after considering the primary, we will make current I1 flow. Just a theoretical concept. Okay. Third one, please. Calculate the magnetic field B21 produced by the current I1. What is the meaning of B21? That means magnetic field at the center of coil 2 due to the current in coil 1. Coil 2 means secondary, coil 1 means primary. Okay. Next one, please. Calculate magnetic flux phi21 due to magnetic field B21. So here please remember the formula here. This phi21 is given by B21 into A2. A2 is the area of the secondary coil, and in question also we have seen both the coils should be in a which plane? Same plane. Then only what will be there? We know the formula like cos theta. So when they are in same plane, then only theta will be 0 degree here. Okay, remember that. Last one, what is given? With the magnetic flux known, calculate the mutual inductance capital M for the pair of coils. And what formula will use here? Capital M, it will be N2 phi21 by I1. Okay, so please remember the formula here. First we have to see magnetic field, then we have to see flux, and then we have to use capital M. And the very basic, we have to theoretically have to make how much current flow? I1 current flow. Okay, so now students, based upon that, now we are going to solve this question in a very easy way. Okay, so steps we have learned. Now let's see here please. Now, so how to solve this question? So see please, let us consider secondary coil of N2 turns and radius R2 is surrounded by primary coil of N1 turns and radius R1. Okay, and in the question what they have given here? They have given R1 is greater than R2. Okay, so students, here I have taken, see please, this is my secondary coil. Okay, this secondary coil, radius how much given? This secondary coil is having radius R2 and number of turns how much? N2. It is surrounded by primary coil of radius R1, and how many turns are there? N1 turns are there. Is it? By seeing the diagram we can see very well R1 is greater than R2. Okay, now students, after that what we'll do here, as we have seen in steps also, we have to make how much current flow? I1 current flow in the primary. This is my primary, red color is the primary and yellow color is the secondary. So see the please, magnetic field B21 at the center of secondary coil due to current I1 in primary coil is given by, as I told you, just it is a language, but the basic, what is the basic? Current I1 is flowing in a primary and we want to calculate magnetic field at the center of secondary. You know very well, the center of primary and secondary is the coinciding, is it? So understand please, magnetic field at the center of primary is equal to the magnetic field at the center of secondary. Why? Because both the centers are coinciding. So here what is the formula here? B21. Now we should know magnetic field due to circular coil. What is the formula here? Mu naught, number of turns is N1, so mu naught N1 I1 by 2 R1. Now this is the magnetic field. Next one please, see please, magnetic flux phi21 associated with the secondary coil is given by. Associated with which coil? Secondary coil. That means which area we have to use? We have to use the area of secondary. That means we can write here, see please, phi21 is given by B21 into which area? A2 area here. Okay, and later we'll put the value of B21 and A2 also very well. Okay, now students, we are going to see the mutual inductance. What is this? See please. Mutual inductance capital M between the pair of coils is given by here capital M. So what is the formula please? Capital M equal to, as I have told you very well, what are the formula was there? Let's go here, see. N2 phi21 by I1. Na? This formula we are going to use here. Okay, so the formula is N2 phi21 by I1. Okay, so here N2 by I1 na, into phi21 is given by B21 into A2. Na? Next one please. N2 by I1 na? And what is B21 students? Mu naught N1 I1 by 2R1 into A2. What is the A2? Area of the secondary coil. Radius how much? R2. So area will be how much here? Circular coil na. So what will happen here? Pi R2 square. Okay. Now let's cancel. What other things are going to cancel? You can see here current I1 and current I1 here cancel. That means this capital M is given by mu naught N1 N2 pi R2 square by 2R1. Okay, this is my formula. Okay, so if you will observe this formula, in this formula you can see very well this capital M is directly proportional to R2 square by R1. Okay, and remember that one more thing, by the mutual inductance formula we can see very well mutual inductance does not depend upon the flux and current. It only depends upon number of turns in primary, number of turns in secondary, and the orientation of the coil, whether the coils are in same plane or the coil in a opposite plane. Okay, opposite plane means some other planes and all. Okay, so by seeing this R2 square by R1, which option is correct here? You can see students, the correct option is here. We have seen now. What is the? We have got M directly proportional to R2 square by R1. That means correct answer here, option D.